everyone, in this video I'm going to be doing the one and only tutorial request that was actually requested. Wingding thing says, is it restricted by language? If not, a simple game tutorial might be nice. So we're going to go ahead and we're going to start on this tutorial. Obviously this was 3 months ago. I've been pretty busy with a few other projects, but for now we're going to go ahead and get started. First thing you want to do is go to your desktop, open a new folder. You can name it whatever you want. I'll call it game. We're going to open up Visual Studio Code and go ahead and drag your game into the folder. Next, we're going to want to set up the live server for our web page. That way we can debug it live. So on extensions, you can type in live server here and then install this one. Once you have it installed, it should have a go live button down here. If not, be sure to restart your Visual Studio Code. Next, we're going to make the index.html file with an exclamation mark tab. We're going to create our game, so we're going to change the title of the game, that way it appears on like the tab thing. Alright, then we're going to hit go live. It's going to open up your default browser minus Chrome. Let's tile this to the right, tile that to the left, and now we can go ahead and get started on the game. Obviously the first thing we're going to want is the canvas. We're going to give it the ID of canvas. This is just so that we can select it a little bit faster with JavaScript. We're going to make a new file, index.js. Now we're going to link the file right here. Link or script source equals index.js. And this is going to be a type equals module. What this does, basically it puts it in strict mode, allows you to import and export, does a lot of different things, as well as you can have a type equals module up here because it automatically has a defer attribute, so it's basically like being down here. So that's cool. Next thing we're going to want to do is we're going to put some inline styles. Normally I wouldn't do this, but this is a very small set of styles that we're going to need, so we're just going to put them all inline. The margin on the body is going to be 0. We're going to make a display block for the canvas. This is just for, on Google Chrome, Canvas often displays as an inline block by default. So this is just so that it doesn't have any issues with margins. Okay, now we're going to test something out. I'm going to say console.log hello. As you can see, it works. Great. So now what we're going to want to do is select the canvas. Const canvas equals document.get element by ID canvas. Great. Now we're going to want to set the width and the height of the canvas to the window inner width and the window inner height. So const width equals canvas width equals window.inner width, and then const height equals canvas.height equals window.inner height. Great. Now we're going to want to retrieve the context of the canvas so that we can start drawing on it. So const ctx equals canvas.get context 2D. I guess the 2D drawing context so that we can start drawing. So ctx.fill rect, this is just to test it out, 002020. As you can see, we've rendered a rectangle at the position 00 with dimensions 2020. Now we can get started on the game. So first thing you want to usually do when you're building a game is build some sort of loop. So we're going to go ahead and get started on that. So we're going to do function loop here. And then inside of the loop, we're just going to request an animation frame of the loop again. This is perfect. Okay. Next, what we're going to want to do is create some sort of scene that can be run on the loop. And then we're going to throttle the frame rate so that way it runs at a pretty consistent frame rate. So let scene equal game, and then game will just be another function, and there might be more functions like game, title, game over, that sort of thing. So what we're going to want to do, I'm going to open a new window. This is just so that I can retrieve a function really quick. These are my projects. I need a function from here. This is a game that I never finished with a few of my friends, but the game loop is really what we want here. It's right here. Awesome. So if I can just, why won't it let me? Okay, that's really annoying. But we're going to basically be copying from here. So then we're passing in then, passing then in here, then going to say const now equals performing. We're going to just copy all this, delete that, and scene. Awesome. And we're not passing in really anything into here. Great. So now how do we initialize the loop? We basically just do loop performance.now. This is going to throttle the frame rate. As you can see, frame time is not defined. So what we're going to want to do is at the top of the code here, const FPS equals 60. We're going to want it to be 60, and then const frame time equals 1000 divided by FPS. Looks like we have another error, players not defined. We don't need that line actually. Great, so now everything is running smoothly. And we can go ahead and test it out in the game loop console.log hi, I guess. And it is running at a clean 60 frames per second, so that is perfect. We want to do some sort of background probably to clear the frame, so ctx.fill style equals, this is white, ctx.fill rect 00 with height. That's from before here. Now we're going to want to make the player. So the player is going to have a few properties. We're going to do class player equals that, or actually not equals, it's just declared like this. Constructor, we're going to give it x and y values, and say this dot x equals x, this dot y equals y, this dot x vel equals 0, this dot y vel equals 0, this dot grounded equals false, this dot keys equals blank. Awesome. So the first thing that we're going to want to do is create some sort of event listener for this player, so that way we can push keys into its keys array. This will be useful later when you're trying to figure out what key is currently being pressed by the player. So we can do set event listeners here, and then we can do, we're passing in a canvas to here, listeners, and we can do this, what we're going to do. We'll say canvas.tab_index equals -1. This allows the canvas to be selectable. And we can do canvas.add event listener key up, and we're setting this dot keys, and we're passing the event to here, event, this dot keys event dot key dot to lowercase equals true. Or no, this is key down, and then we can copy and paste this. This one will be the key up. This one will be false. Perfect. So now we can initialize some sort of player. So const player equals new player. We need an x and y value, so we can do 0 or 2020 actually. 2020. Then we can do player dot set event listeners on the canvas. And now we need some sort of way to render the player, so we can do render. Oh, we should add a width, and we should add a global block size. So const block size equals 30. This will be the block size that we're going to use for everything, since it is a very simple game. So we can do render ctx. We're going to pass in a ctx to the render function. ctx.fill rect, or fill style equals hashtag 12abef is probably pretty good. ctx.fill rect, this dot x, this dot y, block size. Great. So now how do we render it? We can just pass it into right after this background. We do player.render. Cannot set, oh, because we didn't pass in the ctx property. Perfect. Now it is rendering the player perfectly. Next, what we're going to want to do is add an update function. So update here, and then we can say if this dot keys arrow up. By the way, when you're doing the update function, since we're converting the keys to lowercase, you're going to want to make sure every character inside of this property is lowercase, in case you ever decide like, oh, I want to use A, then just use A. So arrow up. If this dot keys, or we're just going to start on arrow right actually. if this dot keys arrow right, this dot xvel plus equals 2. If this dot keys arrow left, this dot xvel minus equals 2. Awesome. And then we're going to want to reset the xvel at the top equals 0. And then, yeah, that's it for now. That's because, oh wait, actually we're going to do this dot x plus equals this dot xvel. It does not seem to be working. That's because we're not running player.update. Cool. Oh, and there's like a weird blue outline, so just go back to the index. We add outline, none. Cool. So now it is indeed running pretty well. Next, what do we want to do? We're going to want to make some sort of blocks. The blocks equals blank. The blocks are to like sort of iterate and check to see if the player is running into something. So we'll also have some maps as well. Const maps equals blank. We're going to use some string maps. There's going to be different levels. For example, this is going to be level 1 array. This is level 2. We're going to start with level 1. So let level num equals 0 because we start from 0 here. And then we do like some random characters and stuff like that. Maybe some variation here. Okay, so now we have some sort of like weird thing set up. We want to read the current map. So that's going to be, we're going to push the values into this blocks array. So we're going to do function set objects or set blocks. This can be run whenever you want, and it will read the current level num associated with the current map, and then fill up this blocks map. So first thing we're going to do is clear the current map, and then we're going to do that by putting blocks.length equals 0. That's going to set the length to 0 and then clear the entire array. Next, what we're going to want to do is retrieve the current map const map const. Actually, no, we can just do for let I equals 0, I is less than maps level num dot length I plus plus. We can do a for let j equals 0, j is less than maps level num I dot length j plus plus. We can do a switch statement here. Switch. We're going to switch the maps level num I j, and in the case that current cell is 1, for example here, we're going to push a new wall into this blocks array. So we're going to do blocks.push, and we're going to push a new array as like a subarray into here. It's going to contain the x value, which is j times block size, I times block size, and then the wall. Awesome. So we do a break here just for good looking code, I guess. Great. So now that we have that set up, we can set the blocks and see what errors we have. Okay, no errors. And then we can log the blocks just so you guys can sort of see what's going on. As you can see, there's an array. It has an x value, a y value, and they're all going to have 0 in the third index, or in the third, index, I guess. That's just because they all have type of 0, which is going to be used to render the blocks. So we're also going to have a render function for the blocks function, render blocks. You know, this actually might be a little easier if we do some sort of class for them. So class blocks. Actually, that's fine. Okay, so we have render blocks function. We can do, how do we want to do this? Well, we can iterate over the blocks. So blocks dot for each block, and basically we can get the x equals, actually we're going to do a destructuring x, y type equals block. Basically what this is doing, since blocks are all in this sort of order, so for example 0, 30, 0, or 20, 30, 0, this would be the x value, and it destructures it into this array and then sets it as this sort of value. So we can do console.log x. It will log the x value of this block, which is exactly what we want. It destructures the y into the y value and the type into the type value. So it's just still like a shorter hand way of writing it. Awesome. So now we're gonna switch the type. Actually, instead of doing 0, we're going to do wall, just to make it a little easier. Case wall. That way it's a little easier to understand. And then whenever we have this wall, we're going to render the blocks with the ctx, of course. We'll do ctx.fill style equals hashtag 1111215. It's like a Russian blue color. I believe that's the correct name for it. And then xy block size. Perfect. Now that we have this sort of wall set up, we can test it out with instead of this rendering loop. So here render blocks ctx. Great. Now it's rendering, and you can go ahead and edit the bitmap if you want. And now we're going to go ahead and get started on collisions, because as you can see, if I were to move the player, he can move straight through. So we're going to set them up. There's a reason why I stopped right here. It's because basically the player needs to separate his collisions into x and y separately. That's just really good practice. Yeah, that's basically all it is. So we're going to go ahead and do for, we could, I think blocks.for each works. Block, and we can go ahead, or actually, there's an easy way to do this as well. We can destructure from within. So instead of doing like what we did before here, you can also destructure here to x, y type. And then x, y, and type are all defined here. Yeah. Okay, so we can do if type, or no, we can do a switch as well. So we can do switch type case wall. And then we need a collide function. So we're going to set this up here at the very top so that it's a little bit easier. We can do square collide. What do we want to do? X and Y probably. And then we can do return this dot x plus block size is greater than x, and this dot x is less than x plus block size, and this dot y plus block size is greater than y, and this dot y is less than block size, or no, y plus block size. And that function should tell us if we are colliding. So next what we're going to do, we can say if this dot collide, and this is referring to the player, if this dot square collide x, y, then we know it's colliding, right? Well, once we know it's colliding, we're going to want to check if he's moving in from the left or the right, because that makes a big difference. So if he's moving in from the left, for example, if this dot x vel is greater than 0, you can say this dot x equals x minus block size. So if he's moving from the right, as you can see here, he's going to stop. But he's not actually stopping, he's just being moved to the side of the block. And then else if this dot x vel is less than 0, this dot x equals x plus block size. So we can't really test it right here. We can try to see if that will work. Okay, yeah, so it is working here. Nice. So now that we have x and y collisions ready, we're going to go ahead and add a y velocity. So we're going to do this dot y vel plus equals 0.25. Great. So after, we're actually going to run y collisions before x collisions. So this dot y plus equals this dot y vel. And it's going to have like a sort of gravity looking thing. That is perfect. That's exactly what we want. It's because we're incrementing the y velocity simulating acceleration. I'm sure you've learned it before, just letting you know now. After that, we're going to want to go ahead and do this, blocks.forEach. We're going to run the collision again, and this time we're doing it for y velocity. Y velocity is greater than 0 equals y, 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 y. Okay, and if it's greater than 0, we're going to set this dot grounded equals true. This is basically if the player's on the ground, it's going to run like that. I don't know why he's like going so incredibly fast, but that's pretty interesting. I'm going to do this, and that works, but he can't jump. So we're going to add the jump. Oh, also we want, when he's colliding, this dot y_vel equals 0, because otherwise he'll just continue falling until he goes straight through. So now we need to add the jump mechanic. So if this dot keys, or actually if this dot grounded equals true, so if he's touching the ground currently, and, oh wait, I misspelled grounded. If this dot grounded, and this dot keys, arrow up, this dot grounded equals false, because we don't want him to be able to double jump, and then this dot y_vel equals negative, we'll do -7. Okay, he's able to jump, he falls pretty slow, so we're going to increase that to 0.28, we'll see if that does anything. And we're going to add like a few rows above this because it's really hard to see right now. Okay, so as you can see, he's able to jump. It's moving very weirdly. About 0.33. Oh, equals. I always forget about that sort of stuff. Okay, so that's why he was looking like he was falling really slow. And that actually might be too much gravity now. You can fiddle with the gravity on your own, of course. But yeah, so now you have a great functionality. What if we wanted to add something like spikes? And I'm going to use precise triangle collisions for this, because I know a lot of people do like, oh, we just make lava and make it a square, but that's not as cool. Where did my toolbar go? Oh, there it is. Oh, not that. Not you, Microsoft Edge. Okay, so I'm going to retrieve one more function from my projects. All the code will be in the description, so you don't have to go and retrieve it from my projects. Right here, I have a precise triangle collision function. It's going to be in here. It's going to be right here. So it looks like we have two dependencies for this. And I'll translate it right now, actually, into this sort of language. Let's see here. So it looks like we need some sort of function to detect side collisions. Actually, we're gonna move the collision functions next to each other just to make it easier to understand. We want side collisions, so side collide, and with x, y. Is that it? X, y? Or p? Okay, p. If we're colliding with p, so we can constant dp equals p minus this dot. Oh, I see why it's like that. P2. Make it. Okay, that's a really weird way of doing it. Oh, I see why. The side-side collisions are combined to make this. So we can just do a square collide there. So we can go ahead and type this sort of function up. This is just the triangle collide with x1 or x and y. Those are the x and y coordinates of the triangle. So const dy equals negative y minus this dot y minus side or block size 5/2. Return if the square collide, if this is square colliding with this, and this x plus block size divided by 2 is greater than or equal to x minus dy, and this dot x minus block size divided by 2 is less than or equal to x plus dy. Okay, so hopefully that is working, because otherwise I don't really know what went wrong. And we can go ahead and add in spikes. So we want to make spikes with up here. Let's just go ahead and make like a little note to ourselves that 1 is for walls, 2 is for spikes. Okay, so we're gonna add a spike right here. First thing we're gonna want to do, case 2. We're gonna copy this, and this is gonna be a spike. Great. Now how do we render the spike? Well, of course we break case spike, and then we want to ctx.fill style equals, let's do red, because red makes a lot of sense. ff, we'll do 4444, because I don't know, I really don't know why. Begin path, I think that should work. ctx.begin path, ctx.move to. I'm trying to think this through. It should be x and then y plus block size, and ctx.line to xx plus block size divided by 2 y, and then lastly we want x plus block size y plus block size. That should be right, and then ctx dot fill. Okay, let's see if that's in the correct place. Yes, it is. Okay, we're gonna move it down here actually. I don't know why, just a little bit cleaner looking. Okay, now we can add in the collision. Since you can see it is indeed being rendered, now we want to add the collision for it. So we break case spike. We can do, actually, we want to run it after we run the collisions, which might sound weird, but here's the thing. Whenever we move here, like say there was a wall right here, and then you fall down, if it iterates to this cell first before it iterates to the wall, you'll die. Whereas in like real life, maybe, well, obviously, you know what I mean. Like in real life, you would fall on the block and then you wouldn't hit the spike. So we're going to iterate twice. This is gonna be the last one. This is a very slow way of doing it. A faster way would honestly be to separate the walls into a separate component, but that's a little bit slower to teach. So yeah, I'll see if you can figure it out for yourself. We'll do a triangle collide. Then we'll add a kill function, this dot kill. And this dot kill is currently undefined, so it's gonna probably throw an error, which I guess kind of makes sense. Yeah, it throws an error. I guess you can kind of see like how the function is supposed to work. It's pretty cool. And now we need to add the kill function. So kill is just going to be a non-argument operator. This dot x equals this dot spawn x, which will be a new property that we're going to add, and then this dot y equals this dot spawn y. And then we need to add the properties, which are going to be this dot spawn x equals x, this dot spawn y equals y. Great. Now that we have those set up, we also want to add a spawn point to our map. So we're going to do 3 spawn. Actually, let's do 9, because 9 is not going to get in the way. Where do we want to spawn? Probably on this, like, yeah, right in the middle. Great. So case 3. We're going to pass a player into the setBlocks function now. So player.spawn x equals j times block size. Player.spawn y equals I times block size. Okay, now that we're passing the player in, we need to move the set blocks after the player declaration, which will be here. So now we're going to set blocks with the player inside of it. And then it's not killing the player, so we need to call player.kill after all the iterations have finished. So we can do that inside of the set blocks function, player.kill. Oh wait, that's case 9, not 3. Okay, now it's spawning the player, and then it kills the player once you fall in. It does seem slightly off. Well, I mean, that works, but when you fall in here, oh no, it's perfect. I mean, it looks like it. Maybe I'm just not getting much precision. Awesome. So now that that's set up, well, we're going to want a goal, right? So the goal is going to be 3, goal. And the goal has a lot of different things to do with it. Of course, it's going to help you. It has a lot of different states that you want to keep track of, such as like the potential that you can beat the game with the goal. So we're going to add the game-winning scene. So in case 3, we're adding a new goal. We want to render it, of course, case goal. We're just going to do a simple green square. We'll do 44 FF, or how about CF, 44. All right, now that we have this goal set up, we want it, when the player collides with it, we want it to take us to the next level. We're also going to move the scene, so let scene equals game. We're going to move this declaration up here. That way we can manipulate it a little bit more. So we have the set blocks function. We're going to collapse that. We want the render blocks function, or next level. Here, we do level num plus plus if level num is greater than maps.length -1, return scene equals game over. So now we need to add the new scene. We're going to add a short one, game over. It's going to be right here. I will do ctx.fill text. You win. Very simple, very straight to the point. Style. And then of course we need the background, that way it doesn't look all weird and blurry once it's over. Great. So now if you've exceeded the maximum amount of levels, you're gonna set the game over. If you remember from before, we're passing a player into here, so we also need a player into here, so that way when we can do set blocks with the player, that should work if I'm not mistaken. Oh right, and then we need to add the next level function to the collision of here. So break case goal if this dot square collide, x and y, next level. Hopefully that is the right order of declaration. Wrong. Failed to execute fill text on, oh, I forgot to add the coordinates. We're going to do width divided by 2, height divided by 2. So, nice. So now you can beat the game. So that's basically all I have for you guys today. I just wanted a short, quick tutorial. I'm probably going to be posting this on my second GitHub because my first one is really for like professional sort of thing. Not really professional. I just like to keep my real GitHub clean. So it'll be on probably the Hopper Chat GitHub. Be sure to download the extension that I've recently created down below if you have Chrome. If you don't, I don't really know what to tell you. I haven't developed it for anything else. Have a nice day, you guys. Thanks for watching.